Hello class. Today we are going to go over Unit 6, Lesson number 5, 6.6 Modeling with Trig Functions. So it's going to be similar to the lessons we've done before. We're just going into more complex word problems, but all the same steps. All of the word problems should represent periodic phenomena. So that means there's wave-like appearances with peaks and troughs, so max and mins. We call these kind of shapes sinusoidal. I know a lot of students, when they see that word, they immediately think it refers to just the sine function, and that's because they sound very similar, but sinusoidal actually refers to any graph that can be represented with a transformed cos or sine function. Okay, so it refers to both. All right, so let's start with this example here. It says the tides in New Brunswick change the depth of the water in the harbor. On one day in October, the tides have a high point of approximately 10 meters at 2 p.m. and a low point of approximately 1.2 meters at 8:15 p.m. So those are two key pieces of information. We've been given our max and min. A particular sailboat has a draft of 2 meters, so it means it can only move in water that is at least 2 meters deep. The captain plans to exit the harbor at 6:30 p.m. Create a sinusoidal function to model the problem and use it to determine whether the sailboat can exit safely at that time. So we're going to have to come up with an equation in terms of sine or cos that represents this situation. And then once we have that equation, we're going to have to find the depth of the harbor at 6:30 p.m. So our first step here is that we have to determine what our variables are going to be. So because we're always comparing time and depth, we know we're going to say let x represent time in hours. When you're working with times on a clock, you're going to want to designate a starting point. So you're going to want to say let x represent time in hours since midnight or since noon. And then you count the number of hours since that, or you can make it any starting point. Because both of the times that they gave us here for the max and min are in the afternoon or in the PM, that means, so that I'm working with smaller numbers, I'm just going to say let x represent time in hours since noon. Okay, you can use midnight though, that's fine. So let x represent time in hours since noon, and then let y represent the depth of the harbor, or you can say d of x, right? You can say whatever you want. So we're going to put depth on the y-axis here, okay? And I already know my max is 10, so that's why I knew to go up by here. So I went up by 2's. And then we're going to do time in hours since noon, okay? And we're just going up by 1's there. All right, so based on this, what information did they give us? So we know the max. They said a high point of 10 meters at 2 p.m. So remember, the time is the x-coordinate. So 2 p.m. is how many hours since noon? That is 2 hours. So the max point is going to be 2 hours since noon, comma 10 for meters. It says our minimum is 1.2 meters at 8:15 p.m. So we have to determine how many hours past noon is 8:15. So I have at the side here, well, we know it's for sure 8 full hours, but now we need to figure out how much of an hour is those 15 minutes. So you're going to do 15 divided by 60, so that represents 0.25 of an hour. So together, 8 plus 0.25 means that our minimum value, sorry, our minimum coordinate is 8.25, comma 1.2. Okay. So we've got those two key points. So we can plot those now, just to get a visual. Okay. So at 2 p.m. it's at 10. And then we're plotting here our minimum of about, and it doesn't have to be too exact here, but 8.25 and about 1.2. Okay. So that's what we know so far. Okay. We will draw that a bit more after, but let's start working on our equation based on these two pieces of information. So A, remember with A we need the amplitude and the sine. So the amplitude is absolute value of A equals max minus min divided by 2. Okay, and we have our max and min values, right? 10 and 1.2. So 10 minus 1.2 divided by 2 leaves us with an amplitude of 4.4. So now what we need to do is we need to decide, based on the shape of our graph right now, it kind of looks like we can see the first half of a cos function, right? So this looks like the first half of a cos function opening upwards. So if I'm going to do cos, I'm going to say if this is cos, then the A value is positive. And that's because I'm assuming that my cycle is going to start at its max right here. So that's going to be the start of the cycle. Okay. So you can call right here x start. Okay. And because of that, then the A value is positive. So my equation is going to have A equals positive 4.4. All right, the D value. The D value always tells us the x-coordinate of the start of the function, and we just went over that here. We're starting our cycle, the start of the cycle is at 2. So D equals 2 hours. All right, so now a bit more work we're going to have to do to find k, because we know to find k, it's going to be 2 pi divided by the period. Our problem right now is that we only have this half here. So based on a cos cycle, if we have the max and then the min, we've basically got half a period, right? So I need to find what the length of this period is, or what the length of this half of the period is, times it by 2, and then that will be the full period. So just noticing that what I've highlighted here in yellow, I'll highlight it here as well, is half a period. Okay, so this length to here is half a period. Okay. So in any sinusoidal function, when you go from a max to a min to a max, it represents half the period. So I am going to do, because the minimum happens second, I'm going to do the x of the minimum minus the x of the max. Okay, so x minimum, x max. So that's going to be 8.25 minus 2. So that means half of a period is 6.25 hours. So if I want to know what a full period is, I'm going to take that number and multiply it by 2. So the full period is 2 times 6.25, and that's 12.5 hours. So I'm going to take that number and I'm going to put it back into my equation here. So I get 2 pi divided by 12.5. Just to show you, if you were to write that as a fraction, 12.5 as a fraction is 25 over 2. A fraction divided by a fraction would give you 2 pi times 2 over 25. And that leaves us with a k value of 4 pi over 25, and that's in lowest terms. So now we have our k. Something else we can also do now is finish drawing this. So I put at the side here, we can find the x-coordinate of the end of the cycle. Remember, we can always do that by doing the d value, so the start of the cycle plus the period. And we know the period now. So we can do 2 plus 12.5, and that means the end of our cycle will be at 14.5 hours. So we're going to start here, and then at 14.5, we're going to return back to our max value. So there is our full cycle, okay, and it should span 12.5 hours. All right, the last letter we need to find is C. C can be found by doing max plus min divided by 2. So we're going to do 10 plus 1.2 divided by 2, and that gives us 5.6 meters. All right, so keep in mind, doing all that work was just so that we could come up with our equation so that we can answer the question without visually just looking at the graph. So our equation is y equals 4.4. Remember, we're dealing with cos based on our U shape. Cos, bracket 4 pi over 25, bracket x minus 2, double bracket, and then plus 5.6. All right, so when they say, is it safe to exit the harbor at 6:30 p.m.? So remember, we need to figure out what value we're subbing in for x. You're not subbing in 6.3 because 0.3 would have to represent hours. So we need to remember that 6:30 is 6 hours, 6.5 hours past noon. So we're going to sub in 6.5. Obviously, yes, we could go to our graph, we can draw a line up like I did here in blue, but that's not going to give us an exact number for the cases where we need to be very close. So we're going to come back down and use our equation. So we're going to sub in x equals 6.5. Okay. All right, so everyone try doing that in their calculator. Remember, you're going to have to do 6.5 minus 2 first. That's going to reduce to 4.5. And you're going to have to do 4.5 times 4 pi over 25. Take cos of that answer, multiply by 4.4, and add 5.6. You should get a rounded answer of 2.8 meters. Okay, so make sure you can enter that into your calculator, okay? So 2.8 meters, so it says this means it can only move in water that is at least 2 meters deep. So this meets that requirement, right? Since the depth of the harbor at 6:30 p.m. is 2.8 meters, the boat can safely leave since it exceeds the 2-meter requirement. All right, let's try another question. This one involves us plotting data, so creating a scatter plot, and then we are going to fit it to a sinusoidal curve. So at this time it says the table shows the average monthly means of daily temperatures in Hamilton, Ontario. Each month's average temperature is represented by the day in the middle of the month. Okay, so these are the average temperatures. I want everyone to kind of do a plot of those right now. So basically what I did here, I did every 2 ticks going up by 5 for temperature. And then we are dealing with large numbers, so I just did every 4 ticks going up by 100. I don't expect this scatter plot to be perfect. Okay, so your blue dots should not make a perfect curve. Okay. Keep in mind in this case, we are going to have to do a curve of best fit. Okay, just like we do lines of best fit, right? In the real world, all the data we look at is not going to make a perfect curve or a perfect line. So once you have plotted your data, I want you to draw a curve of best fit. Okay, everyone's can be a little different. However, okay, your curve of best fit, okay, should always go through the max and min values. So everyone should be the same in that sense. Okay, so it should go through the max and min. So as you've noticed in red here, I've drawn my curve of best fit, and I've made sure that I've gone through the minimum here, which was at day 15, negative 4.8, and then I've made sure that I've gone through the max, which is day 197, 21.9. Okay, so that's what I've circled there in yellow. When you draw your curve should not be going through every single point. Okay, so that's all right. Don't forget to give your let statements. So we're going to let X represent the day of the year, and we're going to let Y represent the temperature in Hamilton in degrees Celsius. Okay, so let's start finding our letters based on our graph. So we're going to find A. So we know that the amplitude is max minus min divided by 2. And remember, we're working with these values as our max and min. So 21.9 minus negative 4.8 divided by 2, which will give us 13.35 degrees Celsius. So that's our amplitude. Now we need to determine if in our equation the A value is positive or negative. So looking at this, right, we've got the mountain shape or the upside down U. So the minute I see that, I think I want to work with cos, just because it looks easier. You can do sine though as well. Because we're starting at our minimum instead of our max, that means our cos graph has been reflected. Okay, so so A is going to be less than 0 since cos cycle starts at its min. So therefore my A value is going to be negative 13.35. All right, our C value is going to be max plus min divided by 2. So 21.9 plus negative 4.8 divided by 2 will leave us with 8.55 degrees Celsius. Our D value is always the x coordinate of the start of the cycle. So our cycle here is starting at day 15. Our K value. So our K is that we're going to have to find, we're going to have to do 2 pi divided by the period. Okay. So we're going to have to do similar to what we did in the last example. Because we drew our curve only making sure we went through here and here, when we drew the curve at the bottom here, we were kind of just trying to be as symmetrical as possible, right? It was a freehand draw. So to be exact, I want you to recognize that half the period, okay, is this length from here to here, right? So from the min to the max. Okay. Now notice because the maximum in this one comes second, that means we're going to do the x coordinate of the max minus the x coordinate of the min, right? You obviously always do the furthest one minus the start. So the x coordinate of the max was 197, the x coordinate of the min was 15, so that gave us 182 days for half a period. So if we want the full period, we're going to do 2 times 182, and that gives us 364 days. Now obviously we know that there's 365 days in the year, so anytime you deal with something with days of the year, you're going to notice that when you do the math, if they use days using whole numbers, you're never going to get like a 0.5 of a day, right? So they're never going to give a temperature like 15.4 of a day. They're always going to use a whole number, so it means you're always going to end up with something like this. So I want you to always, if you get 364, you can just round it to 365 to make sense for the number of days in a year. Okay, and usually the textbook will do that too for anything that deals with a year. All right, so we're going to come back here and then we're going to write that as 2 pi over 365. Okay. And that's obviously as simplified as it's going to be. So we have everything we need. So our equation is y equals negative 13.35 cos, bracket 2 pi over 365, bracket x minus 15, bracket, plus 8.55. All right, now we're going to use this to estimate the average daily temperature in Hamilton on the 202nd day of the year. So remember x represented the number day of the year, so we can sub 202 in the way it is. Okay. For this one, I want you to round to 2 decimal places. So try entering that into your calculator. Okay. And you should get an answer of something very close to the max. And you should get an answer of 21.86 degrees Celsius. So make sure you round to 2 decimal places. So therefore, the average daily temperature on the 202nd day is 21.86 degrees Celsius. All right, and let's move to the next example. All right, so for this one, you might remember it a bit from last year, always something with some sort of wheel that's spinning. A diagram is going to be your biggest help here. So it says a contestant on a game show spins a wheel that is located on a plane perpendicular to the floor. All right, so when you read that, I want you to draw in green, okay, a circle, right? The wheel is above the ground. The wheel is on some sort of stand here that they said is perpendicular to the ground, okay? So you should just be drawing the green part for now. Okay. It says he grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor. So right now, before I fill in more of the diagram, I cannot determine where the red peg is right now. I don't know if it's up here, I don't know if it's here, here, or here. So we're going to have to leave that. And then it says, and pushes it downward. The red peg reaches a minimum height of 0.25 meters. So that minimum height is very important. Okay, so that's going to come into play right here. So that means that this length right here, which I've noted in blue, right? So when the red peg goes around, its minimum is going to be hit right here, and that's 0.25 meters. Okay. The maximum height of the peg is 7.25 meters above the floor. So that means when it rotates up to here, I know that that height is 2.75. So in blue, I want, or in another color, I just want you to put in those two values. And now we're going to start deducing things from that. So what are the remaining things we can find in the question that they didn't give us, just from these two values? So if this length here is 0.25 and this is 2.75, then that means that I could find the distance from here to here, which is technically the diameter of the wheel, okay, by subtracting those two values. So the diameter of the wheel is going to be 2.75 minus 0.25. So this length left over is 2.5 meters, okay, this length for diameter. If I know diameter, then I technically know radius, right? I do diameter divided by 2. So I actually now know that my radius is 1.25 meters. Okay. So it's 1.25 here. Okay. All right, so we've got a lot of information. The one thing that we don't have yet is exactly where the red peg is. So it says the red peg is 1.5 meters above the floor. All right, so we're going to start. So if I start here and I go 0.25 meters up, how many more meters do I need to move up to reach 1.5? So I notice 1.25 plus 0.25 equals 1.5. So I just found out, right, so if I go to the center of the wheel, right, I just found out that this length here, oops, sorry, a little bit nicer, okay, this length here is 1.5 meters. So basically, we just found out that the red peg is directly at the center of the wheel. So it's right across, horizontally across from it. So right at the center. And that's going to be very important. All right, and based on our diagram, it also says that they take the red peg and push downward. So that means when you push on it, it's going to rotate like this first. So it's going to start at this central height and then go down. All right, so it says, sketch one cycle of the graph that represents the height of the red peg above the floor as a function of the total distance it moved. So height is, when they word it like this, that means they want height on the y-axis. And in terms of the total distance moved, that means that they want that as the x-axis. So we're used to x being time. So this is the first time that we're dealing with x being a distance traveled. So that means they're basically asking for what part of the circumference has the peg traveled. Okay, so for example, if they've traveled this many meters, right, what is the height of the peg at that time is basically it. All right, so we're going to let x represent distance traveled by the peg and let y represent the height of the peg. Okay, so let's start off, first of all, with drawing a little bit of a sketch of our diagram, which is really going to help us out. So our sketch here, we can do everything based on our drawing here and our interpretation. So I'm not going to put in the distance traveled just yet. Okay, we're going to do that in a little bit. Right now, I just want you to block off 5 key points. So we know that there's going to be the 5 key points as always, right? So the start, the starting position, the min, back to that original position, the max, and then back to the original position. So our original point is going to be, so if we're doing distance traveled, at this point here, the peg has not traveled any distance. So that's why the distance traveled is going to be 0. Okay? And the height of the peg at that time is 1.5 meters above the ground. Right? So I know my first point is 0 and 1.5. So I'll put that in here. This is 1.5. Notice here that 1.5 is going to be the halfway point between the max and min. Okay. All right, if we push the wheel downwards, the next key point is going to be when it hits its minimum. Okay, so that means this next tick here is going to represent when it goes to its min. Okay. What is the height of the peg then? Well, we know the min height is 0.25. So notice that I'm starting here and then going lower. Okay. So I go, at this point I hit that value, 0.25. After I go to the minimum, I'm going to rotate back up to my central value here, or my starting position, which was a starting height of 1.5. Then after that, I'm going to rotate up to the top, and my max value I know is 2.75. And then obviously our 5th key point should be back to the original position. And that's going to rotate back down to the starting value of 1.5. And there we go. We have one of our cycles. And as you can see, this looks like a reflected sine cycle. So when we do find our equation will be A if we're A is positive if we're working with sine. All right, so now the tricky part, okay, is the height was easy to see, but now we have to figure out distance traveled. So at each of those points. So if we're doing, our first part here is to figure out how long the period is. So the period in terms of distance, okay, so remember it's not time, it's going to be the distance traveled in one revolution. So basically, what length does the red peg travel as it rotates one full cycle? Okay. Another way of saying that, the distance around a circle once is the same thing as circumference. And the formula for circumference is 2 pi r. I can find this exact value because I know the radius is 1.25. So I know that I'm going to do 2 pi times 1.25. And that equals 2.5 pi meters. So that means one full rotation is going to give me a period of 2.5 pi. All right, and that makes sense there. So that's the number that's going to go here, 2.5 pi. So now what we need to think to ourselves, if that's one whole period, when I've rotated from here to here, I have rotated only a quarter of the way through. Or if we want to think about it, what is the angle measure that we have rotated? So if I move from here to here, I have rotated 90 degrees, but we're working with radians now. So I'm going to say I've rotated pi over 2 radians. So that means to find the distance covered in this, I'm going to do pi over 2 times r. Okay? So the angle I traveled times the radius. So that tells me that I have traveled 0.625 pi. Okay, so if you do pi over 2 times 1.25, you're going to get this value. Now, when I rotate back up to the central position over here, so when I come right back to here, I have rotated an angle of 180 degrees, and that's considered pi. So my distance traveled is going to be pi times r, pi times the radius. So 1.25 times pi. And then when I come up to the top, I will have rotated through an angle of 270, which is 3 pi over 2. So that value is 3 pi over 2r, which becomes 1.875 pi. And those will be your x coordinates. All right, we are now going to determine the equation of the function in terms of sine. Okay. So we're going to find our amplitude. Anything that deals with a wheel, obviously you can go and do your max and min formula, but a quick way to find the amplitude when dealing with a circular object, if they give you the radius, then that's the amplitude, right? So you can see here, this would be the amplitude, and it's going to match with the radius value there. So we know the radius is 1.25 meters. And like I said before, because our sine cycle goes to the min after the EOA, right? So it goes to the equation of the axis down to the min. That means our A value is negative. So our A is negative 1.25. Our C value, we know our C value is going to be the equation of the axis. In terms of a circular object, the C value is always the height of the axle from the ground. So the axle is the center of the wheel. Okay, so center of the wheel. Okay. So the center of the wheel, we already know that distance. The center of the wheel is 1.5 meters up, right? It was in line with the red peg. So we have C already. Our K value is going to be 2 pi divided by the period. We know our period is 2.5 pi. So the pi's will cancel out. And then 2 divided by 2.5 is the same thing as 2 divided by 5 divided by 2. Change to multiplication and flip the bottom. 2 times 2 over 5 leaves us with a K value of 4 over 5. All right, and our D value is the x of the start of our cycle. We started at a distance traveled of 0, so that one's easy, D equals 0. So our final equation will be y equals negative 1.25 sine 4 over 5x plus 1.5. All right, I hope everyone enjoyed these word problems. You've just got 5 that you can work on for today's homework. Make sure you practice all of those ones if you can, and let me know if you have any questions. And that wraps up Unit 6 for now. We won't do 6.7 until the end when we can go through rates of change. So when you do the review, only do up until 6.6. All right, good luck, and let me know if you have any questions.